Our first speaker today is Professor Andrew Mente, and I'm very pleased to have him here today. He is mostly associated with McMaster's University and with PHRI in Canada, so he's coming all the way from Canada. Thank you for that, Andrew. And he's very much involved, but he will tell you all about it, with the Pure Study Initiative, which brings in today, for us, the nutritional dimension of sustainability, which is, of course, of major importance. So, Andrew, I'll give the floor to you.
Great. Thank you very much, Professor Frederick, for that generous introduction, and thanks also to the organizers as well. It's a pleasure to be here and present some of the work that we've done in the Pure study and how it helps to inform intake of saturated fat, dairy, and meat consumption in populations, not just in Western countries, but around the world. I have no disclosures, and I'll also add that I don't identify with any particular dietary camp. I'm just here for the science and to present the findings from Pure. Now, as most of you know, the diet-heart hypothesis has been the basic framework that has driven dietary guidelines over the last 40 to 50 years, going back to the 1950s, really, from the time of Ansel Keys and some of the work that he did back in the 50s, and then later the 7-country study. So according to the hypothesis, total fat intake leads to higher total serum cholesterol, and higher serum cholesterol leads to heart attacks or coronary heart disease. Therefore, if we reduce fat intake in the population, we'll also reduce coronary heart disease in the population as well. Now, since that time, when the hypothesis was first proposed, it's been tweaked over the years, where the focus shifted from total fat to saturated fat, and from total cholesterol to LDL cholesterol. But the basic tenets of the hypothesis remain the same: reduce fat intake, reduce clinical events in the population. But unfortunately, it doesn't quite work that way, because this is a very reductionist way of thinking, because it assumes that fats affect only LDL cholesterol and have no other effects on any other biological systems in the body. It's a very simplistic way of thinking, really. In fact, we know that natural foods, like meats and dairy, also contain a variety of other nutrients apart from saturated fat, like B vitamins, protein, zinc, magnesium, retinol, selenium, calcium, and vitamin D. Also monounsaturated fat. So for instance, a slice of one serving of red meat, for example, contains about a 1-to-1 ratio of saturated fat to monounsaturated fat. We know monounsaturated fat is found in things like olive oil, which is thought to be cardioprotective. So you could see, even without even considering actual data on nutrients and blood lipids or clinical events, just based on this, you could see a reductionist thinking focusing only on a single biomarker and a single nutrient really would not work, because foods affect so many other things and contain other nutrients that the body needs. Furthermore, restriction may result in inadequate intake of key nutrients in certain populations. Remember that many parts of the world there's undernutrition, whether it's based on calories or based on nutrient inadequacy. So we have to be careful not to overlook that. In places where there's overnutrition, may not be as much a problem, but many parts of the world there really is serious undernutrition or frailty or stunted growth, etc. So we don't want to compound the problem by restricting intake of nutrients that people need. And that should be kept in mind as well going forward. And then last thing, before we get into the actual Pure data, the current dietary guidelines on carbohydrates, WHO recommends about 55 to 75% of energy from carbs, and about 15 to 30% of energy from total fat. So basically they recommend higher carbohydrate diets for populations. And some guidelines, like WHO recommends less than 10% of energy from saturated fat, And some guidelines like AHA and NCEP, even lower amounts, less than 7% of energy from saturated fats. That's a very low amount of saturated fat, very difficult for most people to sustain, even in the short term, let alone long term. It basically amounts to taking on a vegetarian diet. Just going back one slide, I should also mention that it should also be kept in mind that the average intake, the average intake of saturated fat in Western populations is approximately 12% of energy. It varies a bit from country to country, but it's about 12% of energy, which is just slightly above the current WHO recommendation of 10% of energy. So it's not like there's a saturated fat emergency where we're consuming 20 or 30% of our calories from saturated fat. It's only just slightly above the recommendation. And so that 12% should be kept in mind as I present some of the data from PURE. It's not just the shape of relationships, but also the level of intake that needs to be kept in mind. So that brings us to the first of our papers from PURE, where we looked at the association of dietary nutrients with blood lipids and blood pressure in 18 countries around the world. This is now the cross-sectional data from PURE. That is data collected at baseline, both on nutrition and on blood lipids. So I'll tell you more about the PURE study. So PURE is a large global epidemiological study, and it's a prospective study. So we recruited, now in the first wave of countries, 135,000 people from 667 communities in 18 countries around the world. And these people are being followed up. And up to now, we've had 1 decade of follow-up of these participants in PURE. So we have all this data to look prospectively at relationships between diet and future clinical outcome events. In this analysis, we focus on the cross-sectional data, looking at blood lipids with nutrition. PURE also spans 5 continents of the world. Why is that important? Because when we study multiple world regions, we study diet diversity. So we capture a broad range of intake from very low levels to very high levels. So now we could look at, for the first time ever, to look at shapes of relationships between dietary exposures and health outcomes. Not just whether there is a relationship, but the shape of the relationship across a broad range, from low to high levels, with a high degree of statistical precision. Never really been possible before in any other study, because PURE covers multiple world regions. And also, please note that the target sample size in PURE is 200,000 people. We're close to achieving that target after our second and third wave countries that have since joined PURE. For this analysis, we focus on the first wave countries. So here are the countries that are included in PURE. They include the countries shown here by geographic region, which includes South Asia, China, Southeast Asia, Africa, North America and Europe, Middle East, and South America. Now, this is cross-sectional data we're looking at for this particular analysis. PURE involves an unbiased selection of individuals from the general population in 667 urban and rural communities around the world in 18 countries on 5 continents. And in this analysis, we focus on 135,000 people with nutrition information aged 35 to 70 years without cardiovascular disease at baseline. Diet was assessed using country-specific validated food frequency questionnaires, which is the standard approach for large population studies. And the food questionnaires were specifically developed and validated for each country, and more specifically for each urban and rural area of each country. So a lot of work went into even just developing the dietary instruments that were implemented in PURE. We also collected detailed information on all known confounders and covariates, demographic factors, other lifestyle factors like smoking and physical activity and alcohol intake, and health history and study center. So in this analysis, we have information on blood pressure in 125,000 people, blood lipids on 104,000, and ApoB and ApoA measurements in a subset of 18,000 people from these countries. And we use standard multivariable regression analyses to analyze the data. So this slide here shows carbohydrate consumption versus the cardiovascular risk markers. So on the top left, you see carbs versus LDL cholesterol, the central tenet of the diet heart hypothesis. You could see with higher carb intake from where participants are subdivided based on quintiles or fifths of intake, from the lowest quintile to the highest quintile, carbs ranging from about 49% of energy to 69% of energy. So that's a pretty broad range of carbohydrate intake in a population. And we see that LDL cholesterol goes down with higher LDL, with higher carbohydrate consumption. So there's an inverse association. However, we see that HDL cholesterol, the so-called good cholesterol, also is lower with higher carbohydrate consumption. So when we look at the ratio of total cholesterol to HDL, we see in fact that it goes up. So higher carbs are related to higher total cholesterol to HDL ratio. Now remember from large epidemiological studies that total cholesterol to HDL ratio is a stronger risk predictor of future heart attacks and stroke than LDL cholesterol. So now the dietary recommendations, they focus on one number, LDL. So based on LDL, with this data, we would say, oh, eat more carbs. But if we look at total cholesterol to HDL, a stronger risk marker of future clinical events, you get the opposite advice. You would tell people to eat less carbs because that goes up. We also see triglycerides also are higher with higher carbohydrate consumption. That's consistent entirely with what we know from randomized controlled trials. Higher carbs related to higher triglycerides and lower HDL. So on the basis of this, what do you recommend? The answer is it depends what biomarker you focus on. The current focus is on LDL, but if we focus on other important risk markers, you get completely conflicting dietary advice. The point is you need studies of clinical events. That's the bottom line. Intermediate markers don't cut it. You have to study clinical events, major cardiovascular events, and mortality long term. This is also important from the standpoint that the results are completely consistent with what we know from data from randomized trials. That's important because it also further validates the accuracy of our dietary assessments. Since we see similar results from what we would expect versus independent physiological markers, it provides further assurance about the accuracy of our dietary assessments. It's another layer of validation, and that's important too. Now, ApoB and ApoA, we see higher carbs are related to lower ApoB, which is the harmful apolipoprotein. But we also see it's related to lower ApoA. That's the protective apolipoprotein. So when we look at the ratio of ApoB to ApoA, we see that higher carb intake is related to higher ratio of ApoB to ApoA, suggesting a harmful effect. Now remember, in case you don't know, that the intra-heart study and the intra-stroke study showed that ApoB to ApoA ratio was the strongest lipid marker of future heart attacks and stroke in both the intra-heart and intra-stroke study. Two international studies, large international studies of myocardial infarction and stroke. And so ApoB to ApoA was the strongest risk marker. And it's a measure of the small, dense LDL particles that are more atherogenic than LDL cholesterol. So it's a very strong risk marker. And there's remarkable consistency across geographic regions of the world. So it's a very important risk marker. And so as I mentioned, we see that higher carbs relate to higher ApoB-ApoA ratio, indicating possible adverse effects of higher carbs. We also see higher systolic pressure with higher carbs. So collectively, to recap, if we focus on LDL, we would say eat more carbs. But if we focus on any other risk marker, we would say eat less carbs. That's the collective findings on carbs. Now what about saturated fat? Well, with saturated fat, we see the flip side. We see higher saturated fat associated with higher LDL cholesterol. Now note the change in saturated fat. That's a big change from 4% of energy in the lowest fifth to approximately 12% of energy in the highest fifth. That's about a triple increase in saturated fat, all the way up to about 12% of energy. So we see LDL goes up by about 0.4 millimoles per liter, which is a pretty modest change considering the large change in saturated fat. On the top right, you'll also see that HDL also goes up, the so-called good cholesterol. So when we look at the ratio, we see the opposite of what we found for carbs. We see it's related to lower total cholesterol and HDL ratio, which suggests a possible protective effect, at least up to 12% of energy from saturated fat. And we also see lower triglycerides, which also suggests a protective effect. Again, up to 12% of energy. So certainly from these data, if we focus on other risk markers, apart from LDL, we would say consuming up to 12% of energy from saturated fat is the optimal amount. Lower amounts may actually be harmful. If we focus on LDL, we'd say, no, you need to limit your saturated fat. So it depends, again, on the risk marker. Again, we need to study clinical events. And what about ApoB to ApoA ratio? We see ApoB goes up, but ApoA also goes up. So when we look at the ratio of ApoB to ApoA, it suggests that saturated fat is related to lower levels of, lower ratio of ApoB to ApoA, again suggesting a protective effect. Systolic pressure, however, goes up. So collectively, we find that LDL and systolic pressure suggests possibly lowering saturated fat would be better, but all the other risk markers, like important ones like ApoB to ApoA ratio or total cholesterol to HDL ratio, suggest that higher is better. So again, we need to study clinical events. So to conclude, on the basis of the data looking at cross-sectional information on blood lipids, reducing saturated fat and replacing it with carbohydrates has an adverse effect on blood lipids. Focusing on a single lipid marker like LDL alone does not capture the net clinical effects of nutrients on cardiovascular risk, and our data are at odds with current recommendations to reduce total fat and saturated fat in the diet down to low levels that are currently recommended. Now, these data, they don't show that 20% of energy from saturated fat is optimal. No, because the highest fifth was around 12% of energy. But certainly, it does not support lowering down to low levels as currently recommended. That's really the point. Now, what about clinical events? Up to now, we've looked at lipid markers. What about the bottom line is really to lower heart attacks, stroke, and death in the population. That's really what it's all about, right? So looking at the data from previous studies, this is a meta-analysis by Siri Torino, published 2010, where they looked at the highest consumers versus the lowest consumers of saturated fat in these prospective cohort studies versus coronary heart disease. And as shown in the slide here, when they crunched the data, crunched the numbers from all this data, they basically got a summary estimate that was neutral, showed no relationship between saturated fat and coronary heart disease, the central hypothesis of saturated fat intake. They did find a lower risk of stroke with higher saturated fat, and it was statistically significant. Now, our group reported the exact same findings a year earlier in a paper published 2009 in Archives of Internal Medicine, but we looked at 30 dietary exposures overall, one of which was saturated fat. And when we went into that analysis, we had no preconceptions. But when we first saw those results, we said, that's peculiar. We were expecting to find saturated fat to be harmful because you hear about it being artery clogging and so on and so forth. And so, nevertheless, we found that the numbers were correct. We published the paper. So a year later, this study supported our earlier finding, which is reassuring. Then in 2015, our group also published another paper where we updated the analyses of saturated fat versus clinical events in a paper published in the British Medical Journal. And from these cohort studies, we looked at these various other outcomes, and we found that they were statistically, again, neutral. No relationship between saturated fat and total mortality, coronary heart disease and cardiovascular mortality, cardiovascular disease, total ischemic stroke, and type 2 diabetes. Now, there actually are randomized controlled trials of saturated fat replacement in the diet with polyunsaturated fat versus clinical events. Not intermediate markers like cholesterol, but actual clinical events, MI, stroke, cardiovascular events, or mortality. So what do these data show? Well, here are the most recent meta-analyses over the last 4 or 5 years that have been published, saturated fat versus coronary heart disease. And you see the relative risk estimate from these meta-analyses. And you could see across the different meta-analyses, the point estimate and the 95% confidence interval shows that the replacement of saturated fat with polyunsaturated fat is statistically neutral. So in other words, this is a direct test of the diet-heart hypothesis in randomized trials, and it showed no benefit of replacing saturated fat with polyunsaturated fat, again, based on randomized trials, consistent with what we find in the cohort studies. And in the interest of time, I'll skip this one. And okay, so to summarize, saturated fats are not associated with all-cause mortality, cardiovascular events, or type 2 diabetes. Replacing saturated fat with mostly omega-6 is unlikely to reduce cardiovascular events and mortality. So that brings us to the second of our papers from Pure. This one published in 2017 in the Lancet, where we looked at the association of fats and carbohydrates, but this time with actual cardiovascular events and deaths in the same participants in the 18 countries. Now, it's also worth noting that this was the first ranked, this was ranked as the #1 paper of 2017 by Digital Science in their annual Altimetric Top 100 Research Papers of 2017. So in other words, this was the most widely discussed paper on social media in 2017. And so here we look, as I mentioned, the prospective data, 135,000 people, same participants as I mentioned. Note the large number of clinical events. We had more than 4,700 major cardiovascular events and 5,700 total deaths accrued during the median follow-up of 7.4 years at that time, 7.4 years of follow-up. And we use standard multivariable Cox regression analyses to analyze the data with center as a random intercept. So this slide shows the risk of mortality on the left and major CVD on the right by macronutrient intake. So first, looking at mortality here on the left, we see carbohydrate consumption in the different quintiles, from the lowest quintile, 46% of energy, to the highest quintile, 77% of energy. And you see here that higher carb consumption is associated with a lower risk of with a higher risk of mortality, all the way up to the highest quintile of carbohydrates, with a hazard ratio of 1.28. So people in the highest quintile have a 28% higher risk of death compared to people in the lowest quintile of consumption, with a graded association observed in the cohort. For total fat, we see the opposite. Fat ranging from 11% of energy to 35% of energy, we see that higher consumption of total fat is associated with a lower risk of mortality, with a hazard ratio of 0.77, which means basically a 23% lower risk in the highest consumers compared to the lowest consumers. Protein intake also is related to lower risk of mortality. On the right, for major cardiovascular disease, we see neutrality. Both carbs and fat, as well as protein, are not associated with major cardiovascular events. Now, what about different types of fat? Saturated fat, monounsaturated, polyunsaturated. So for saturated fat here on the left versus mortality, we see that saturated fat ranging from 3% of energy all the way up to 13% of energy in the highest quintile. We see a graded association with lower risk of mortality all the way up to the highest quintile of saturated fat with a hazard ratio of 0.86. Monounsaturated and polyunsaturated fats also show a similar relationship. Higher amounts related to lower risk of death. So each type of fat is associated with a lower risk of death. For major cardiovascular events, again, we see neutrality. We see no significant association. So really, when you think about that, it's actually consistent on the right for major cardiovascular. It's consistent with the Siri-Torino meta-analysis. Remember, we found that they reported that saturated fat was neutral versus coronary heart disease and other cardiovascular events, and inversely related to stroke. But here we focus on major cardiovascular events. We see neutrality, which is consistent with previous meta-analyses. Now, what about CV death and non-CV death? So cardiovascular death on the left, we see higher carbs directionally are associated with higher risk of cardiovascular death, whereas total fat and protein are related to a lower risk of cardiovascular death. We see the opposite. It's not statistically significant, though directionally we see these trends. For non-cardiovascular disease, that's where we see our biggest signal. So higher consumption of carbs is related to higher non-cardiovascular death, whereas by contrast, we get the opposite for total fat and for protein. Higher intake is related to lower non-cardiovascular death. Now, what is non-cardiovascular death? In Pure, after 1 decade of follow-up, this is largely cancers and respiratory deaths. So that's really what's driving it. Now, at this point, after about 9 years of follow-up in Pure, we don't have enough clinical events on individual types of non-CV deaths, like cancers or individual types of cancers or respiratory deaths or other types of non-CV deaths. But as we continue the 2nd decade of follow-up in Pure, we'll be able to get enough events and where we can look at this a little better and explore the nature of the relationship with specific types of non-cardiovascular death. Now, what about different types of fat and CV death and non-CV death? So on the left, we see saturated fat trends toward a lower risk of cardiovascular death, and each other type of fat similarly trends toward a lower risk of cardiovascular death. More markedly, we see a lower risk of non-cardiovascular death for saturated fat and also for monounsaturated and polyunsaturated. So each type of fat is associated with lower risk of cardiovascular death, but even more so, non-cardiovascular death. Now, in the interest of time, I'll skip over the next 2 slides where we discuss the strengths and limitations of Pure, perfect material for the discussion afterwards. So that, now, a question that often arises is our higher intake of death among people consuming higher carbs driven by fruits and vegetables? And the answer is no. We actually looked at that in a 3rd paper published in the Lancet, led by Victoria Miller, who is my graduate student who recently graduated with her PhD. We looked at fruit, vegetables, and legume consumption versus cardiovascular disease and deaths in the same participants in Pure. And you see the results here. On the left, risk of mortality, and on the right, risk of major cardiovascular disease by total fruit, vegetable, and legume consumption in servings per day. So on the left, you see for mortality, higher fruit and vegetable and legume consumption up to 3 to 4 servings per day is associated with a lower risk of mortality, and we see maximum benefit at 3 to 4 servings, and then the risk is constant with higher levels of intake all the way up to 8 servings of fruit, vegetables, and legumes a day. For major cardiovascular disease, we see a trend toward lower risk with higher consumption, but it's not statistically significant. So the higher risk of mortality we see for carbs is not from fruits and vegetables. If anything, they're protective. It's from refined carbohydrates. Because remember, in Pure, we're representing largely low and middle income countries. We have about 20% from high income countries, but 80% is low and middle income countries. And in these countries of the world, fruit and vegetable consumption is actually quite low. So it's mostly the refined carbohydrates and refined wheat products that are driving it. We now have another paper that we have an advanced draft that we're about to submit for publication in which we report on that. So it's not from fruits and vegetables, but rather refined carbs. So higher carbohydrate intake above approximately 50 to 55% of energy is associated with higher mortality. Fats, including saturated and unsaturated fats, are associated with lower mortality. There's no association between total fat, types of fat, and cardiovascular events. We do see a lower risk of stroke with higher saturated fat. It's consistent with previous studies. So the current advice to limit total fat to less than 30% of energy and saturated fat to less than 10% are not supported by these global data. So in the last year, we published another paper. We looked at dairy. So dairy consumption now in 21 countries. We have 3 more countries in which we had sufficient follow-up information to include in this analysis. So now 21 countries around the world on 5 continents. We looked at dairy consumption versus clinical events. So this slide here summarizes the results, total dairy versus clinical outcomes, looking at composite of death or major cardiovascular disease, total mortality, and major cardiovascular events. And for each outcome, you see that higher dairy intake compared to non-consumers, higher consumption up to greater than 2 servings per day, the highest intake group, is associated with a lower risk of each type of outcome, with hazard ratios ranging from 0.84 to 0.78. So about a 15 to 20% lower risk in the highest consumers compared to the lowest consumers. And what about other types of death or other types of events? We see also an inverse association with non-CV death, with cardiovascular death, with MI, and most strikingly for stroke. Higher consumption related to lower risk of stroke with a hazard ratio of 0.66. So the inverse association with stroke, which is particularly striking, is totally consistent with what has been reported in previous studies. So dairy does seem to be protective against stroke especially, though we see inverse associations with other outcomes as well. Now, a question that arises, okay, is it whole fat dairy or is it low fat dairy? Now, in most of the countries in Pure, apart from the 3 countries from North America and Europe, in the other 18 countries, it's mostly whole fat dairy, predominantly whole fat dairy. And so on the left, we see the analysis for whole fat dairy alone, and we see clearly inverse associations, higher consumption related to lower composite outcome, mortality, and major CVD with higher consumption. On the right, when we look at whole fat combined with low fat dairy, the signals are not as clear cut. So clearly the association of dairy with lower clinical events is largely driven by whole fat dairy, not by low fat. And then we looked at different types of dairy. Yogurt and milk, for each we see an inverse association. So higher intake of yogurt or milk is associated with lower risk of each of the major outcome events. For cheese, we also found an inverse association, higher cheese related to lower risk of events, though the effects were more modest and just barely not statistically significant. For butter, we found complete neutrality. There was no association at all between butter intake and each of the clinical outcomes. That's reported in more detail in the paper. Now, what we also did is we did subgroup analysis where we subdivided the countries based on level of dairy intake. We took the countries where there's a very low intake of dairy versus the countries where there's higher dairy intake. And what we found was that in both regions, in the low intake region and the high intake region, the associations were similar. We see an inverse association, higher intake related to lower risk of cardiovascular events and death. Now, why is that important? Because when we look at within populations, we're less concerned about confounding by poverty across populations. So that if we see within populations a similar association, then it's more reassuring that the effects are less confounded by poverty. Of course, in any observational study, you cannot completely rule out residual confounding, but you just do what is humanly possible to minimize confounding as being a major factor in your study. So higher dairy consumption is associated with a lower risk of mortality and cardiovascular disease, and a particularly lower risk of stroke. And so just to update you on Pure, we have a next wave of papers that will be coming out hopefully in the next 6 months, maybe the next 12 months, we'll see, depends on the peer review process. Here we will report on red meat, poultry, fish, eggs, and nuts versus CVD and mortality. Also a diet score paper where we look at diet in its totality. We presented this information in, if we have like 5 minutes, we presented this information at the European Society of Cardiology meeting in Munich last year, and I'll show you the results here, where we looked at diet in its totality. It's the overall diet quality. And so we looked at data from 4 large international studies, 218,000 people around the world. Pure, and I told you about Pure, general population cohort study. 31,000 people in the on-target study, which is people with vascular disease, and 2 international case control studies of MI and stroke. And note the large number of clinical events accrued during the follow-up in the 2 cohort studies and the large number of cases in the international case control studies. 3 of the studies are global, while on target is North and South America, Europe, and some parts of Asia. So what we did is we created a pure healthy diet score based on the foods that were related to a lower risk of mortality in pure, in 138,000 people around the world. And the foods related to lower mortality were vegetables, fruit, and legumes, which is one of the papers that I showed you, nuts, fish, dairy, which is the other paper we showed you, and unprocessed red meat and white meat. And so what we did is created a scoring scheme where each food receives a score of 0 or 1 based on whether intake is above or below the median. A total diet score is simply the unweighted sum of each protective food with a minimum score of 7 and a maximum score of, a minimum score of 0 and a maximum score of 7, where 7 is the highest quality diet. So this shows you what a low and high pure healthy diet score looks like. Here we report for clarity the lowest and highest quintile of the diet score. So the lowest quintile represents the unhealthy diet, and you see the consumption of various nutrients and foods. 1 serving per day of fruits and vegetables, 0.4 servings of nuts and legumes, 0.3 dairy, and very little red meat and fish. So note carb intake is almost 70% of energy, whereas fat is less than 20%. So those in the lowest quality diet score are consuming a very high carbohydrate diet. And again, as I mentioned, mostly refined carbohydrates, not fruits and vegetables. By contrast, the healthy diet score is one that had where people consume 4.5 servings of fruits and vegetables, 1.5 servings of nuts and legumes, 2 servings of dairy, 1 serving of red meat, and 0.3 servings of fish. Note carbs and fats are more balanced, 54% of energy from carbs, 28% of energy from fats. So in other words, an all-around balanced diet with carbs and fats in moderate amounts, and each of these foods consumed together all in moderate amounts. So this is not an extreme diet. It is not a keto diet. Okay, this is an all-around balanced diet that includes a variety of foods in moderate amounts. And so we look at risk of mortality by healthy diet score in pure, and we see, just to cut to the chase here, after full multivariable adjustment for known confounders, we see a graded association all the way up to the highest quintile of the diet score with a hazard ratio of 0.75, about a 25% lower risk in those from the highest quality diet compared to the lowest quality. And then we took the same score and we applied it to the other 3 international studies that I mentioned, and we see a similar pattern of results. In the people with vascular disease and on target, and the 2 international case control studies of MI and stroke. So the pure healthy diet score comprised of fruits, vegetables, nuts, legumes, fish, dairy, and meats is associated with lower risk of mortality and CVD globally. There's consistency across 4 international studies and consistency in people with vascular disease and without vascular disease. Some elements of the pure score, such as dairy and meats, differs from current advice from earlier studies, but perform mostly in high-income countries, whereas pure is global. So this is what we recommend based on the pure data going forward: higher fruit, vegetables, nuts, legumes, dairy, and meats, eat less refined grains and sugar, processed meats and sweetened drinks, and minimize your industrial trans fats. And so I think I'll stop there. Sorry, I went a bit over time, but thank you very much. Thank you.
Thank you very much for this fascinating talk. We'll try to squeeze in a couple of questions, not to run too much over time. So if anybody in the audience would like to...
Congratulations on your very excellent lecture. Oh, sorry, thank you. I have one question. All these things are less carbohydrates, more proteins, more fat. There is one important word that you didn't mention, that's satiety.
Yeah.
That means this is very important. Fat gives a lot of satiety, so you should also take into account the sensory things about it. Why do people eat too much of something?
Yes, agreed. Yeah, satiety is a very important part of it, and previously we thought about it while there's 9 calories in 1 gram of fat, 4 calories in carbs. We should eat more carbs. But satiety really is a key point, and yeah, thanks for mentioning that. Now, the paper wasn't focused on that, but it's important to point out. Yes. Thank you. Good point. Thank you.
Thank you for your excellent presentation. I have one question. How different is your healthy diet from the Eat Lancet diet? It's a true question. I didn't.
Yes, it's a serious question. No, I agree. It's obviously different from the standpoint of the animal products. It's completely night and day different. I mean, we also, in the same data set, we derived a Mediterranean diet score, and it was pretty similar to the pure diet score, although Mediterranean diet has, it calls for a bit less red meat and dairy, but generally we see a similar pattern. But our score does better than the healthy eating index, which is more of a low-fat diet, and directionally you see inverse associations with risk with the alternative healthy eating index, but it's not nearly as good as pure or Mediterranean diet. We plan also to derive a Eat Lancet diet based on our data to test that. We could do that because we have the Eat Lancet report and we could develop a score based on that, so we can actually quantify it scientifically to see how that performs in this data set. So that's something we can, in fact, the paper is being written right now, and that's something we really thought about and we might add to the paper. So it's a good point, yes.
Thank you. I was wondering, you talked about carbs and fats. What is the role of salt in all the story?
Yes, great question. Oh, there's a big story right there, an entire lecture on that one. But I'll just give you the overview. So Pure has covered sodium a lot. We've had 4 or 5 major papers, 2 in New England Journal, 2 in the Lancet, 1 recently in BMJ on salt. So what Pure is showing is what about a dozen other studies are showing, in that there's a sweet spot for sodium in the middle, between 3 to 5 grams, associated with a lower risk of major cardiovascular events and death. And there's remarkable consistency across different studies, whether they measure sodium using morning fasting urines or using 24-hour urines or using dietary assessments. There's not one study ever, and I mean in history, showing that low sodium at currently recommended levels does better than average sodium in the population versus clinical events. So all they really have is short-term trials of sodium and blood pressure under the assumption sodium affects only blood pressure, but nothing else. When in fact, we know sodium is an essential nutrient. The body needs sodium. It's not like tobacco, where tobacco we know you don't need, right? Sodium your body needs. And so it's not logical to think of sodium affecting only blood pressure. You would expect sodium to affect other aspects in our physiology, like renin and angiotensin II, for example. And indeed, we find at low sodium that these neurohormones are activated, which completely explain the increase in risk at low levels. And consistent with every essential nutrient, where you would see a sweet spot in the middle, and an increase at the low end, an increase at the high end, where being in the middle is optimal, as you would expect with every essential nutrient. But every time there's a really a big challenge to conventional thinking, paradigm change really does take a long time. So gradually, we would expect as we publish more science, there will be change in the guidelines eventually, I think.
Thank you very much, Andrew. Thanks a lot.
Thank you.